database. I end up doing this occasionally, but not so often that I forget what's the motivation here. So examples of what we've done in Indeed. So the Indeed has a new organization called Indeed Hire. Have you heard of Indeed before? Oh, good. Okay. So Indeed is the world's biggest job search engine. We have tens of millions of jobs, we have tens of millions of resumes, and what we basically do is we try to match them up somehow to employers or job seekers. We have a new business called Indeed Hire, where we have recruiters. We have a team of recruiters that will make those placements, which is great because a lot of times Indeed try to figure out how good they are, how that fits their right, stuff like that, and how we can talk to people who work for Indeed and figure out why they do the things they do. So one of the things looking at things like how often we have to keep business from existing clients, and then we also looked at to see the interval between the dates on which a new job requisition was created. And then because we're finding sometimes the client will start a new job within a day or two of starting of giving us one. And that's not counting, but then how far out you go. You go a week, a month, and so on. So being able to kind of look for the intervals is actually important there. And the other kind of thing I end up doing sometimes is looking at our recruiters' media profiles, we try to figure out, well, how much time does it take, how much time are they spending actually dispositioning profiles, and some of them are very fast and depends on the job, of course. So looking for the time interval between each disposition they change during profile review is one way to try to get a sense for that. And of course, we have to see things like word possession and so on. All that said, rather than try to try out and explain a whole bunch of the data, we'll stick with the census data. And we'll look for scene changes. I don't know quite how to find scene changes per se, but one way that we might approximate it is to look at, well, if you've got a new location, right, is one way that you might look at it. It's probably going to have some noise in there too, but you might go back and forth quickly, but that might be one way to do it. It turns out there are 407 rows in our original data frame where the location is 0. Fortunately, those are also the ones where the raw location text is empty, and they happen to, and they'll co-occur each other. And so just, again, there's still some noise in it, even though we can know a bunch of things. Okay, so here's some examples of lines where there is no location. Okay, and we could go in and try to look for some ways of interpolating this. In fact, I started down this path in December notebook of data cleaning. So it turns out a lot of these things are so many things are due to just, munged up quotation marks in the original CSV file, so interpolation may not be a good way. So with that understood, so it's also the case, just like there are some location IDs that have, or some character IDs that have multiple location text values. There are also location IDs that have multiple location text values. Okay, and that's one of the things that are not all lowercase and not all normalized. It's one reason why those other ways of referring to the same thing. There are some of the most frequently occurring locations. The Simpson home, the school, the tavern, and so on. And then at the other end of the spectrum, we can look at some of the infrequently occurring location text values as well. You can see there that we have a mix of all uppercase and mixed case as well. Okay, so how many people have used the shift function in Pandas before? Okay, this is actually something that Net introduced me. I was struggling. So in my head, I was trying to figure out how to do some of the analyses earlier. I said, oh, you try shift? Oh, no, okay. So one way that we might identify location changes is look for changes where the location of the current script line is different from the location of the previous script line. Okay, so again, we'll look at just the first few rows of our data show that the locations are 1 and then there's 4 lines associated with location 2. Okay, if we apply shift to the location, what that does is it shifts everything down 1. So this 1 now shows up in the second row of the shifted series. Okay, so we have 1 there, and then these 3 2s show up here on row 2, 3, and 4, so that's the end rows 1, 2, and 3. And then because there was nothing by definition before row 0, that's a null value. Okay, and then just we can also shift up. So that's quite straightforward. Apply there, but now we can see that by using shift -1, you can shift things in the opposite direction, and you can do more than one value. And you can actually shift by time, for take time, all kinds of time offsets. There's lots of, it's a very powerful function, but we're not going to go into all that here. We've already everything organized in rows, so I'll go here about just shifting a little bit. Okay, so first we will group by episodes. It looks like I'll put them this later. I'll try to be consistent internally here. So we first group by the episode, and then we take the location ID field and we shift it. Oops, I forgot to put period back in. Okay, so it turns out, because we previously already stored the data frame based on IDs, all 5 of the first lines in the script are essentially from the first episode, so we get the same value. So what we can do here, though, is, again, because I like working with ints, this only works because there is no location 0. It was a 0-based indexing system, and this would not work because it is a 1-based, the number starts at 1 and we can count 0 as null values. We can essentially do the shift. We can use fill in A, fill the null values with 0, and then convert everything to int64. Okay, so now we have a field with infinite, with 0 is a substitute for the null values. And then we can add that into the main data frame by essentially referencing a new column name with the value of, let's see here, just so it all shows up on the screen, that last thing, that last line. And then I will show you the full data frame. But there you can see that everything kind of shifted down 1. Okay, so now we went through, whenever location and the location ID and the previous location ID values don't match, we've got a scene change, more or less. To me, the data set, we have a bunch of zeros, 4 and 7 rows, right, where there's a script line, there's a 0 location, but again, for the moment, we get that. Okay, so, final exercise. Oh, sorry, good. Well, it's meant to be easy. Okay, so how many scene changes are there across all episodes? What we can do is just take we can train the data frame, looking for the rows where the location ID and the previous location ID are not the same, and then just take the length of the resulting data frame. Okay, so it's like, over the course of the history, there are 17,000 or so scene changes. And just to kind of double check, whenever I do something like that, I kind of like to see, well, what's the flip side of that? What are the number of rows where they are the same? And that's a pretty high number, and unfortunately it is. So, I guess I'm really fortunate that my intention was to end by 11:45, so there'd be time for questions, comments, or early punchline. So, that's the end of the notebook. I'll stop there and open up to any questions. Yes.
So, if you're going to do this table, you really want to do 2 things. Part of that is improving by location, and then choosing how you order by. I think by default, it's ordering by whatever it is that they prefer to order by. Is there any way to specify how you want to order when you're shipping?
So, you want to be able to change the order of the ship?
So in case you're doing that, sorted properly, is there a way within the shipping and stuff to tell it how many line orders when you're going one after one forward?
I'm not aware of one. I would probably sort at a time, either in sort of everything or apply sort operator somewhere along the line in the chain calls. What's over there? So the question is, what do you do when you have big data instead of small to medium-sized data like this data set? Are you asking specifically about the shift operator or in general? Yeah, that's a good question. I so far haven't tried to apply this on data set that's more than say 1 million records, which is at most medium. So I haven't exhausted memory or other kinds of problems. So I haven't encountered anyone have any suggestions generally for how to deal with that. To ask. Is there a tutorial later today, right? Okay. So that might be a good question to address there. Other questions? Yes.
Hi. Thanks. This is a fun tutorial, the Simpsons application. I have a question about the final output of like your two examples of Indeed or the Simpsons. So now that you somehow kind of made consistent these uneven spaces, how do you show the time series, or how's that applied?
So in the examples of where I was looking for the gaps between new requisitions from the same client, what I actually was using was not these are like order rings, but actual date time values. So I essentially had the dates of these things, and I could use command way to manipulate offsets and count the number of days, and then divide that by 7 or a lot of these or other kinds of mechanisms to try to get a sense for that.
Okay, so the final output of this analysis is essentially like a metric that you're looking at, it's not a time series?
Yes, so in this particular case, what we're trying to find is count the number of distinct requisitions that represent repeat business versus new business. And so what the key was trying to filter out when we have more than one requisition, they occur too close to the first requisition we want to discount, and then different people have different ideas about what that should look like. So we want to see how the overall count will be affected for sales numbers.
Thank you.
Other questions? Yes. Yeah, so the question is for, let's see if I can find it here. Why am I using the loc function rather than just the bracketed way of referencing columns in right here? The reason is, I just got into this habit, I don't know if I need to here, but anything is warning message whenever I do these assignments, just using the old way of bracketing things because it's either a copy or a panel or a view, and so I just got into the habit of referencing things via the location when I'm using label versus positional references. I don't know if it's necessary here, it's just a habit I've got into. Other questions? All right, thanks. Don't forget, we're wrapping up our drones. Stop by the Indeed booth.